So welcome again to our Elasticsearch Taste of Training webinar. So what we're going to be doing today is we're going to be looking a bit into how we do training, and also we'll be looking at some example content for that. The way that our trainings is set up, we get all kinds of different trainings set up. There are some longer trainings which can take 2 days or maybe 4 half days if you run them as a virtual, and some very concentrated trainings down to 2 hours. So what we'll be looking at today is some content that's actually been pulled from one of our more advanced trainings, okay? This is actually our Elasticsearch Engineer 2, which is part of a 2-part series, okay, here. So usually people would have come, that have gone through Engineer 1, and in Engineer 1, typically people find out how to spin up Elasticsearch, how to spin up 1, 2, 3 nodes, how to start looking at different roles for their nodes, and how to actually work with using those. So Elasticsearch Engineer 1 kind of gets you up and running with a 3 to 5 node cluster. If you want to scale it up to 10 nodes, that's fine. Now in Engineer 2, this is where we get bigger. Okay, we go all the way under the hood. We start looking at segments and things like that. If you've never met segments, don't worry. We're not going to drill deep into segments today, I'm afraid. So segments are where we basically come into Engineer 2, and then we look at everything else you need so you can think about how to scale really big and to go really big. Now, scaling is a big issue for a lot of our clients who are at that level, basically. And in this webinar, we're not going to have a chance to go through absolutely everything there. So what I'm going to do is I'm just going to focus on a couple of particular facets which are inside there. Also, we should have a chat open. So please feel free to fire any questions that you've got into the chat. What I'll probably be doing is picking up those questions kind of from about 25 minutes when we're through this. Then I'll start working my way through as many of those questions as we can go through. And we'll be aiming to kind of like wind up around about 1/4 to the next hour. So what I'm going to do now is I'm going to actually share part of the platform that we use for our online and for our in-classroom trainings as well, to actually give you a little feel for how we do the trainings, and then we'll use that to actually drill into the content itself. So you're going to get a slightly different view here than you would get if you were consuming our class in a classroom environment, because I'm actually going to show you kind of like the instructor view of how you'd actually see this, but you'll get a pretty similar experience here. So I'm going to drop now into the platform. So this should now allow me to move into that, and you should, yeah, okay, great. So you should be seeing that now. So you should all now be seeing the platform that we use. So this is an online web platform. Our users can log into here. Typically, if you're seeing this in the classroom, you'll also in the classroom experience will be showing up on a projector these exact same contents. But this is a useful platform because this allows us to do, for example, we can run through our labs inside here. So you can basically spin up a whole cluster using virtualization and containerization technology here inside this application. Everybody's got their own cluster to work with, and you can kind of work through there. Also, as we'll be looking at later, there's a whiteboard here. So this whiteboard, it's slightly smaller than I'd be using in an in-person class, but the good news is the pens never run out of color, so that's great. So presentations here, and we'll also be looking at a demo a bit later. So I'm going to start walking gently now through the content. So typically what we'll be looking at in a 2-day training is working through all of these. There's 9 here. Actually, we have a 0 module because we're like very tech, as you might have guessed. So we like to start with 0. The 0 is the kind of the hello and all the kind of getting everything spinning up, just making sure your lab's working kind of stuff inside there. So typically what we do, step through what's inside Elasticsearch. There's some stuff on modeling and fixing data where you can like see how to actually kind of like munge your data, etc. And then digging deep into aggregations. Cluster management is where we start looking at how to actually spread the technology over multiple resources. So if you're looking at multiple zones, for example, this is a nice one. See people doing really interesting stuff with spots inside there on cluster management. And then capacity planning, which is where the content I'm going to pull now is actually derived from. So what I'm going to do now is take a dive straight into capacity planning now. So we'll drop into here. So typically in the capacity planning, we'll talk about how to design for scale, because at the end of the day, it makes way more sense to actually think, oh, this is how I would like to scale. So you can set up a way of actually scaling in like a linear way, and hopefully use Moore's law to actually decrease your TCO by content as you increase. Okay. And that's where capacity planning comes in. Really, the takeaway in this particular class is that we tend to do a lot of detail on capacity planning, on helping people figure out how big their biggest shard should be for a specific use case. That's kind of like the real key thing that you have to figure out inside there. Okay, so I'm just checking that I'm still presenting inside there, on that side there. So there may have been a slight discontinuity there. Should be back now. Um, okay, so I'm just sorry. I'm just checking with our AV team, and they're just giving me some feedback to check that I'm live. So we're all good there. Apologies if there was a slight discontinuity there. This is the internet. This kind of stuff can happen all the time. So where were we? We're talking about capacity planning, the possibility that we really want to dig in to understand what is the ideal size of our shard, because that ideal size of the shard, I kind of think of that as kind of like as like the red construction brick that we can basically build up our indexes from and figure out how to actually scale our indexes out. But once you've figured that out, there are other techniques which you can actually use to increase throughput and to increase volume. And those are generally scaling with replicas and indices, because when you figured out the right size of the shard as the basic unit, if you want to work with that, just checking that the AV again. Can you hear me okay now? Okay, splendid. So I'm just going to do a quick refresh on Hangouts just to hope that. Okay, so we should be back now. Okay. So again, apologies for internet stuff. It's usual when we're on the internet. So we're going to look at scaling with replicas and how then I'll be whiteboarding how we can use that to drive throughput inside there. Okay. And also I'll look at scaling with indexes or indices, excuse me, how we can use that to actually scale out horizontally to get more size. We won't be digging deep into the use cases because I don't think time will really permit on that one today. So scaling with replicas. Now, I'm just going to drop into demo mode for a moment, just to do a quick refresh on what happens when you try and add indexes inside Elasticsearch. So let me just fire up a screen share there on the, now we're going to fire up Kibana here. So you should be able to see Kibana now. Yep, that's great. So, okay. Yeah. So oh wow. So I just got a refresh on the chats. This all came flying back in. Okay, interesting question there. So by the way, I just saw Artie's question, storage, RAM, numbers per nodes and stuff like that. I won't be giving concrete examples on what are the ideal sizes for nodes and things like that, because the reason for that is that that is totally tuned into your use case. Let me give you like an example on that. Let's say, for example, I'm indexing some data with a vanilla Apache log, 10 million lines per day, and I've got like 10,000 queries per day coming into that. Now, somebody else might have another vanilla Apache log, all the same length lines, 10 million lines per day, 10,000 queries per day. You might think they're getting exactly the same thing. But if, for example, my particular use case is, for example, I'm running like a web store, okay, where the total vocabulary of the data that's actually getting put into my web store is really quite small. There's some long URLs, but then there's an integer at the end of it, and it's all pretty much the same thing. Somebody else has got a lot of SEO driven links inside there. Now, here, if we see what the size of what's actually behind that, it could be radically different, okay? So even though we've got the exact same amount of content coming in, if somebody's content is driving a different use case, they could have a completely different pattern of what's stored inside there. So anyway, what am I showing here on the screen right now? Well, here I'm logged into Kibana, okay? And I'm just drilled in to look at the default indexes. These are the indexes that we should typically run inside our engineering too. Let me see if I can stretch that out a bit to get the stuff there. So you can see you've got quite a lot of index content inside here. Now behind each index, as you probably know, we've got some shards inside, okay? I'm just going to drill into the shards now for this particular index. So I have an index called log server 1. Now remember, an index, it's a virtual namespace where we store a bunch of data, and up to and including elasticsearch 6.x, the number of shards in your index would have by default been 5. Now that 5, it wasn't like a magic right correct number or something. It was just basically a number that we were putting out there so that it made people aware of the fact that you can shard an index, okay? Now, to be honest, if the size of your index was, I mean, really, I've got a really tiny index here, okay? I've got like 33.6 megabytes in that shard. They're all about 30. Actually, I could put all of this data inside one shard, okay? But for the sake of argument, we're running it here. Now, let's say I want to do some updates on this index. I'm going to change my settings. I'm going to say, I don't want 5 shards. How about if I had 6 shards? So let's see what happens. So if I send that request in, you know, Elasticsearch is going to push back and tell me, no, I'm sorry, you can't be updating the number of shards on an index. Now, the technical reason for that is it's all down to routing, okay? Basically, if I fire up my index and I start putting some data in, I put a document into shard 0, I put another document into shard 1. Well, if I start adding new shards, that's going to completely mess up the routing that was being done to actually put that stuff there. So that's kind of like the basic reason why we don't let you generally tweak shards on the fly, okay? There's APIs and stuff that can let you work around that, but we're looking at designing a solution where you're not actually going in directly to do that. So starting from the fact that I'm not going to be able to change the number of shards, okay, as we'll see here, I'm still back at my 5 shard index. What happens if I add a replica? If I add a replica, now things get interesting. So now we'll see Elasticsearch has said, okay, let's fire up some replicas, and it's built some replicas. Because I was quite quick in there, we could actually see that it got there before these replicas were actually fully built. But if I refresh that now, we'll see it's fired up and built replicas of everything. Okay, now I can add more replicas, okay? Maybe I want to boost it up to 3 replicas. We're going to see in a minute why I might want to do that, okay? I'll boost that up to 3 replicas. Now Elasticsearch is in the situation where it's got some replicas running, okay? It's trying to build this one right now, and it hasn't actually got enough resources to run that one there because at the moment, you may or may not have noticed I'm running node 1, node 2, node 3. I've only got 3 nodes in this case, and Elasticsearch doesn't want me to put multiple replicas of the same data on the same resource. So that's why it's pushing back on that one there. So I'm going to dial that back to a slightly more sensible. I'm going to go really conservative, dial it all the way back down to 0. And there we are. We've got our replicas back down to 0. So as you can see, I can push replicas up and down. So let's drop back into the presentation now, okay, for a moment, and see how we can actually work with replicas now that we've established that I can be flexible about the number of replicas that are actually configured in the settings of my index at any point in time. So back in here, so let's see, scaling with replicas. We can add these. So initially you'd think they're there for high availability. This is the idea that if something breaks, okay, I lose my primary, it's not a big deal if I've got a replica for that, because as the replica's got exactly the same data inside it as the primary, Elasticsearch can immediately promote that replica to be a primary, and then we're back to having all of our data available and all of our indexes indexable. So I can put data in without loss, and I can query and have a consistent query across the full data set. Now that's the high availability angle. Now from a scaling point of view, what we can do is we can then add the fact that we can scale for read and search if we've got enough hardware inside there. So let's take a look at how that might work here. So if we start off with just one shard and one node here, now I could dial up the replicas to 1 there. Remember, it's a dynamic setting as we just saw in that little demo now. So now I've got 2 copies of that data. My index is now spread across node 1 and node 2. So to be honest, I've got a whole intact index on each of these here, okay? Now let's see how that actually impacts the scaling side here. So here in the whiteboard, I did a bit of drawing to actually kind of get slightly ahead here. Usually we'd be building this, but as this is the web, thought we'd try and get ahead. So let's see what we've actually drawn here. So this should be, there we go. So just checking what colors we have there. So we've got 2 nodes here. I've got node 1. So here's my node 1, and here's my node 2 inside the indexes. So the 2 nodes are the 2 resources. Now then I've got index 1, and my index 1 is the resource, the virtual namespace, which is actually implementing an index across node 1 and node 2 in this case. And my configuration is currently, I'm actually set up with, just move the keyboard out of the way so I don't have any involuntary elbow tests here. So I'm actually running with 2 shards and 2 replicas. So I've got my 2 shards and my 2 replicas inside there. And at the moment, what I could do is, let's say node 2 goes down, then node 1 would promote replica 1 to become primary 1, and that would ensure that we've got coverage of all our data. Now, from the scaling point of view, this is where things get very interesting if I start seeing a query. So let's say I have a query coming in from a web client here, and a query coming in from a web client here. Okay, so I've got my 2 queries coming in. Now, what can actually happen is at the moment is a query needs to be distributed across all of the shards. So for example, what might happen is my query might come into the cluster, and let's say it comes into node 1 here, and then node 1 decides to distribute that query, for example, across, it's going to send that to 1 copy of each shard. So we're going to go to primary 0, and we're going to go to, in this case, it could go to primary 1 on node 2, or it could go to replica 1 on node 1. It really doesn't make a difference. Apart, there's a bit more network traffic, but all the hard work is happening down at the shard level, okay? So that's where the hard work's happening inside there. Now, from the point of view of scaling, on Q2, let's say my other query is coming in now. I'm going to route my other query through at this stage to node 1 at this stage. But now what could happen is node 1, depending on exactly how you configure stuff, could basically say, well, what I'm going to do is actually, I'm going to route that query through to these resources here. Okay, so now what we can do is we can send the query. We're sending these two queries and they're being serviced in parallel. So that means if one query takes approximately X seconds, then my two queries running in parallel are going to take still approximately X seconds. There's going to be a slight bit of latency going on, but this allows me to scale horizontally. So let's say, for example, we're expecting, I don't know, Black Friday's coming up or something. We're expecting a big boost in throughput, or the national lottery numbers are going to be published tomorrow or something. Then what we could do is we could simply spool up more replicas by adding more hardware, temporary hardware. We add those replicas, and that allows us to deal with a lot more throughput there as we're actually working with the content. So I'm just going to go back and check the questions and see what's coming in here. So some cues coming in here. Okay, so reviewing here. Okay, Henry's question on SSDs. Okay, yeah, SSDs are great. We really like SSDs. They're fast. They're also more expensive. So typically with SSDs, what we'd really be looking at there is some kind of a tiered storage pattern, where probably you'd place some of your data on SSDs and the data which doesn't need to be on SSDs, probably put that on cheaper disks. So I'm going to be talking about scaling with indexes in a moment there. Okay. Some more ones here. Okay, copies of shards. Shards should not be larger than 50 gig, according to Tim Norris. Now, that is a very interesting statement. There's been lots of debate on this. The fact is, the shard, it depends on what index data you're actually putting inside it. Okay. Some people will find for some hardware that they can go beyond that number. Some people find for some hardware that that number will be more than what they can really take. And this is why we do stress a lot in, particularly in engineering too, in this scaling chapter here, that you can gain huge value and add a lot of value to your whole storage system by doing the detail and figuring out for your use case what actually works. Because, for example, if you're going to be running with 1,000 indexes or 10,000 shards or something like that, the savings that you can make by having an accurate estimation of what's the best size shard for your data could really be very impactful there inside. Okay, 2 shards, 1 replica, 2 shards, 1 replica. Not quite sure what you got. When I say 1 replica, it's 1 replica per. Oh, hang on. Let me just go back to that one. Yeah, sorry. Correction. Yeah, 2 replicas. Just adding in a correction from Ugo's one there. Yep, that should have actually read 1 replica on that one in that one. Yeah, sorry, my bad there. Okay, thanks for spotting that one there, Ugo. Okay, let's drive back to here. So routes and load balances the queries between the 2 nodes. Okay, that can happen at different levels. If you're using one of our official APIs, the APIs will make an attempt to actually load balancer stuff inside there. So, for example, the Ruby API, what that does is it finds what nodes it can talk to, makes a list, randomizes that list, and then round robins over the randomized list. Now, inside Elasticsearch, Elasticsearch is also aware of any nodes which aren't responding, and in V7 might be able to actually skip sending stuff to a node which is responding. And on top of that, what you can use is you might want to use in older architectures, we've been promoting the idea of a dedicated coordinating node, which is to use a node which neither stores data nor has master administration functionality, nor is used for indexation, simply to be a software load balancer. However, price-wise, we're now saying, yeah, node 1 and node 2 are both data nodes in that case. Price-wise, what we're seeing is that now the price of load balancers in cloud or on site is getting to the level where it's getting quite close to what you could actually get with the software load balancer and just a very simple server. So again, it's a question of doing the numbers and working out which one fits best to your use case. So if we move back to scaling with replicas here, we can boost the number of replicas there. That's the dynamic setting there. Okay. Now cost, it's not free. Okay. So slower indexing speed, there will be parallel indexation. That's the good news. Okay. Inside that, but it will actually take more resources. So that's more happening there. Definitely more storage on disk. For every replica, you need the equivalent amount of space on disk inside there. And the shards which are actually running those ones will need more heap memory inside that. So yeah, replicas don't come for free. Now let's take a quick look at scaling with indices. So you saw earlier when I ran the quick demo that under normal circumstances, without using specialized APIs, we wouldn't expect to be able to increase or decrease the number of shards in a given index. But what you can do is you can use multiple indexes to actually provide scaling. So if I'm just going to go back for a moment to the demo screen there, that should be going back to the demo. So there we go. So back over here, we were running with logs server 1 there. So now, in fact, what's actually going on inside there is, as well as log server 1, I've actually got some more indexes there. So I've got a log server 1 and a log server 2 and a log server 3. So now I can go from 5 shards, add a log server 2 to get some more shards here. So actually, by spreading my data over 3 indexes, I can actually have, for example, 15 shards quite happily running here. So that allows me to scale horizontally. And this is where the question earlier on about SSDs is interesting as well. Perhaps what I might want to do is put my latest data. For example, if I'm only writing to log server 3, maybe I could use the techniques discussed in an earlier chapter of Engineering 2, which actually allow us to steer shards to one or other specific hardware device based on tags on those devices, which could relate to the hardware, could relate to the zone, etc. By steering the shards here or there, we could basically route them to devices which have got SSDs or don't have SSDs, so that we're only spending the extra money where we're actually expecting to get extra value. So for example, in logs case, you might imagine that log server 3, these are my latest logs coming in. I want those available now because I'm using those actually to monitor the uptime of my system and check that everything's running. Now, maybe log server 2 are logs from last month. I want those available because I'm doing triage, trying to work out where something went wrong. And log server 1, they're from last year. I want those available at like a lower SLA, because at this case, I'm only interested in them if I've basically got to look up for retention, basically. Maybe I've got like a legal retention on those or something like that. So scaling with indices, let's move back to the presentation now. Dropping back into presentation again. Again, by the way, thanks to our provider Strigo, who actually use this index here. So here, what we could do is by adding indexes, this gives scaling. Now, this statement at the bottom here is very important. Searching one index with 50 shards is equivalent to searching 50 indexes with 1 shard each. Okay. There are very slight differences regarding latency and network effects, etc. But the big picture, okay, the kind of the O end of the picture, is that what's going on, all the hard work is going on at a shard level. So in both those scenarios, it's all happening at the shard. 50 shards are impacted in both cases, so it's pretty much the same thing. So this is how we might choose to set that up, for example, there. So we could set up one index, define our index with 4 shards, and that will be distributed over 2 nodes. That's fine. Or maybe we define 2 separate indexes with 2 shards each. We've got the same number of shards to distribute our data. In the first case, the upper case, we've got a simpler management scenario. In the second case, we've got more flexibility. You can imagine perhaps we might be adding put my index 3 to add 2 more shards next month in this case. But the downside is there's a bit more of a management overhead. So we need to have our configure management all in shape to actually be able to drive that one there. I'm going to jump back and check the chat. Let's see what's going on in the chat here. So, okay, consistency when queries read the replica instead of primary from Andrew Ching. So there, when the queries read the replica is synchronized to the primary. Okay, so inside Elasticsearch in Engineer 2, we have like an extensive discussion of exactly how the synchronization process inside Elasticsearch. Elasticsearch was designed to distribute data over multiple indexes. So we really have done the detail on how to make sure that everything is synchronized inside the indexes there. An index with multiple mapping types. Okay. If you have multiple mapping types, okay, moving to ES7, one index per mapping type. I think you might, I'm assuming what you're saying with mapping type, I'm assuming you're talking about doc types there, document types. So for those, performance-wise, the good news is that one of the main drivers for actually moving things into, I'm just going to drop back to the, drop out the screen share again for a minute. So one of the main drivers, so a question here, multiple mapping types moving towards ES6 or 7, is that good or bad performance? One of the main drivers for actually removing the mapping types is that by having two different kinds of mapping, you may remember I mentioned earlier that the key thing to tune in an index is the size of your shard, okay? So if I'd had in a version 5 index, for example, one shard which has got my logging data and one shard which has got my user data inside that, then I can't tune to my logging data and to my user data. They're different use cases. Now, if I separate those two indexes out, then that allows me to define these shards for this data and these shards for this data. Everything can be optimal. So yeah, that would be driving you towards being more performant inside there. Yeah, on that one, yeah, on type is deprecated. Yeah, so the answer is bad. Regarding that, there's no bad answers. Okay, what actually happened is in 6, basically, we wouldn't allow you to define multiple types inside 6. When you get to 7, however, you actually have to ensure that your requests are not actually trying to push in not even the type. So we don't even want you to push in a type at all, not even a default type inside there at 7. How complex is the process for defining a new index on the same beat input, say based on time, like you mentioned? Okay, that's a great question. So the way that beats and logstash as well are actually set up, they're kind of by default set up to produce time-based indexes. So they will be producing time-based indexes, but those time-based indexes are probably running on like a day-to-day basis. So what you would probably be really, the question there is not, how do I get my beats to create me a new index every day? The question is really is, how do I manage the indexes which were created by Beats for me last month to perhaps consolidate those daily indexes down to a month? How do I manage the monthly indexes which I created with my consolidation process last year and get those all consolidated down into one yearly index, for example, something like that? This is a concept which, unfortunately, it's outside of the scope of what we're digging in today. But if you want to check on the Elastic documentation online, we've got a lot of information about index lifecycle management, which is where you want to go to answer that kind of question there, okay? Now, does searching multiple indexes versus a single index affect relevance scores? Okay, that depends on the number of documents per index. So for example, if you have 2 documents per index, then you could expect wild variation in the results because relevance is based on the terms which are actually inside the index. And if you only have 1 or 2 documents per index, extreme exaggerated case there, you would get wild variation there. However, if you have millions of documents per index, that's going to balance out. That's going to be very smooth inside there. So I wouldn't expect that to be a big issue inside there. Do we need to alter any setting from indexes as segments merge hampers CPU IO during business hours? Okay, segment merge. Now that's an interesting question as to why that was happening. If you want to drill into segments merge, that's a very long conversation. It's a rewarding conversation, but it's a long conversation. We dig into that actually in the first chapter of Engineering 1, where we have a long talk about segments merge. On that one, I'm not sure from the question. I have seen a few blogs out there suggesting, even blogs by people who are partners to Elasticsearch, who perhaps might not have put this. Don't provoke your segment merge. As I can see from you, it's hampering the CPU IO during business hours. For me, the question would possibly be, if that's hampering the CPU IO, perhaps something else is happening, which is preventing the segment merge or making the segment merge not happen as smoothly as it would be. So perhaps if you're doing something with snapshots, or if you're doing something with using the APIs to actually scroll through the documents. If you're using scrolls, please make sure you're only using scrolls for back-end processes and not for front-end processes during business hours, for example, because that may slow down your segment merge and give the appearance that the segment merge is what's slowing you down, when in fact what's slowing you down is the fact that you're preventing the segment merge happening more quickly. Data retention by default in ELK. I'm afraid that's a very wide question inside that. Data retention, basically the data stays except for monitoring data. If you're monitoring your cluster, then will by default be 7 days. Everything else just stays there until you actually manage it out of your retention period. Indicators to check the performance of the indexes. Ooh, okay. If you're getting a 429, start figuring out why. Okay, that's the one to watch for. So if the indexes start pushing backwards, saying we can't index stuff any faster, then you'll start getting 429s. That's a time to start thinking about implementing your horizontal scaling strategies. Webinar for rolled up indexes and index management. I think that's an excellent topic for a webinar. I will feed that one back in to make sure. I'm just dropping in a note now to make sure that we actually get that one scheduled as a request, because I think that one's a great idea. And we're actually working on when we're going to get the content to actually deal with roll-up indexes and index management there. Difference between an ingest node and a log stash. Okay, that one's kind of out of scope of what we're looking at today, really. So for that one, I'm just going to give a quick answer, which is if it's an ingest node, then you've got everything inside Elasticsearch. So if you want to change, if you've already indexed your data into Elasticsearch and you'd like to modifying it, then using an index node is going to be a lot simpler than taking it out and putting it back in. However, if you wanted to decorate your data using a third-party web service, for example, calling out to an external database for a lookup, then you go Logstash. 10 indexes, daily index of same data, single index pattern on Kibana. I'm going to drop back in one moment there. I'm just going to move slightly forward with the just to finish off the Prezo there, basically, to roll that one out here. So yeah, here in this one, typically, by the way, we would have finished this with a few questions. So we'd throw in a summary, say, boost your replicas to get more throughput inside there and get horizontal scaling through multiple indices. Then we'd throw in a quiz. True or false, an index with more shards can support higher ingest rates. Okay, question there. You can drop that answer into the chat there if you'd like to do that. And the answer to that one is that if you have more shards, you can support a higher interest rate because, for example, if I've got a whole bunch of documents and I'm firing them all at the same shard because I've only got one shard in my index, that one shard with however many disk heads it has available is going to do all the work. If I split my index across a whole bunch of shards, then I can spread the load there. Okay. Adding replicas is a reliable way to back up your data. No way. Please use snapshots, use backup again, use more snapshots. Do it, please. So, and there's your answers inside that. Yeah, for backup, you should take snapshots and more snapshots. Then we'd follow this up with a lab, typically some questions. And then here's a splash sheet on the full course and the syllabus inside there. So I'm just going to drop back and grab a few more questions there. Let me see. So, okay, great. Indexes, single index pattern. Okay, Mahen, question. You have 10 indexes, daily indexes of data, and have a single index pattern in Kibana to query your data. Okay, I'm assuming if you created that index pattern with a wildcard in the end, then it will work. You can federate that over your indexes. But what I would say you might want to look at is take a good look at aliases. Okay, find out about aliasing, because that allows you to manage exactly the relationship that you're trying to ask about there. So you can control the relationship using aliases inside Elasticsearch. And yeah, if how to optimize to interact with only the required indexes, that is exactly what the alias would allow you to do. So for example, you could have an alias, all my indexes, and an alias is my indexes of interest. And you could route the query to one or the other, and you'll be able to manage those and then get a layer or extraction to actually affect one or affect the other inside there. Okay. Yeah. Thanks to Matt for flagging that blog there. Okay. Possible parameters which causes memory. Okay, things, there are so many things which can cause memory and CPU to go high. Inside those, the big candidates, trying to do bad things with doc values when you should be doing with keywords. Well, it depends. Right approach to decide the sharding, Elastic Guess 992. The right approach to decide the sharding is to figure out the maximum size of the maximum optimum size of your shard. Okay. So you do that, basically spin up your use case, put in your real data, not fake data, real data, fire user queries at the real rate at that data, and then just keep firing the data in, building it up until you start getting 429s back. That's how big your shard could be. And then when you know how big your shard can be, just work horizontally. Okay. Again, we do the detail on that over a couple of chapters, basically, inside the Eng 2. So sorry if that seemed a bit brief. Recommended more nodes with less resources and less nodes with more resources. Okay, nice question. Because more nodes, you could run a bunch of containers on them. But if somebody trips over the plug, you've lost all those nodes. At the end of the day, I did say that I wasn't going to mention numbers, but we do like to keep each Elasticsearch node to around 30 gig of memory normally. Memory, that's just the memory. And everything else you can factor up or down around that number, really. Yep. Max docs in each time-based index, max size of an index. When is X gig bad? So yeah, max docs in each time-based index. Again, this comes down to how big should my shard be? So what you might want to do is perhaps think about how big should my shard be? Now, probably your daily index, unless you're like trying to index the fire hose, is not going to get up to that max size of a shard there. So what you'd want to do is maybe use a bunch of shards for your daily index to spread the indexing load, get some SSDs on there or something. And then moving forward, maybe look at how to group them up until you reach X gig, when X gig is your optimum maximum size shard, and then just don't group beyond that. Other than 4 to 9, search index latency. So on that, if you enable elastic monitoring, this is not a sales prezo, that is a licensed functionality. But if you enable Elasticsearch monitoring, you're basically going to get some really sweet graphics that just basically show you when things are starting to tail off. So yeah, when it starts going downhill, or when your search time starts going uphill, that's going to give you a lot of help there. A link that shows applying universal scalability law to Elasticsearch. I haven't seen that link. If you do see that link, I'd love to see it myself. Do shards operate similar disk striping with parity? Configurable, basically. Inside that, you can tell Elasticsearch to stick the shard just on one disk, or you can let Elasticsearch just follow your RAID configuration inside that. Pros and cons to both. Again, we dig deep into those in Eng 2. It's quite a long conversation. Preferred ratio between data nodes and client nodes. Okay. So for client nodes, there's not really such a thing as a client node in this case. When I was drawing some clients earlier on in the picture, really referring to kind of like external, an API or a caller actually calling in there. High memory and CPU, again on that one, there are so many things which could cause high memory and CPU. Basically, you could have one weird document in which would cause high memory and CPU inside that, or you could have parameters causing that. So really that one, if you're having issues with high memory and CPU, again, not a sales plug, but I would recommend sticking Elastic monitoring on to actually allow you to at least do a root cause analysis to figure out where you've got that issue inside there. Does client nodes are necessary? Quote as old architecture. I'm sorry, I don't know what a client node is. I haven't seen it in the version 6 or version 7 or version 8 documentation. Okay. Capacity planner tool. Yes, that would be a nice idea. Now, regarding it depends, you may or may not have noticed, I've studiously avoided saying it depends without actually qualifying it here. I don't like saying it depends. However, it does depend. It depends on so many factors for capacity planning. As I mentioned, you could have two use cases which look exactly the same and have completely different disk footprints. This is why we recommend that you actually do the detail. Because you could take an Excel spreadsheet, just click on that link, it comes back and says your shard should be 5 gig or your shard should be 500 gig. There's going to be a cost difference associated. So by doing the detail on that and not just doing it once, by thinking this is a life choice, this is an ongoing process. I'm going to repeatedly come back and do the detail and check that this is working. Why? Because if I'm running an architecture, as do many of our clients with thousands of nodes inside there, you're going to have huge performance and price benefits for doing that detail inside there. Single disks versus multiple disks on data node inside that. That depends on what else is inside the box inside there. It's basically the relationship between the number of shards and the amount of memory. Again, we'd have to drill in that. Alternative to scrolling for getting a large amount of documents. It depends what you want to do with a large amount of documents. You could do deep pagination if you want to get a large amount of documents, and that large amount of documents is inside your actual ongoing business process. Then basically design into the whole sizing exercise the process of getting that large amount of documents. So basically scale to get the documents. So don't think, oh, I'm going to use a more aggressive API and worry when my system breaks. Think, oh, I need to get a large amount of documents every X. Let me put that into my system and actually test to make sure my system can deliver that SLA there. Anyway, we've gone 4 minutes over. I'm going to hang on for 1 minute with a few more questions on that one. By the way, just to say thanks to everyone for being here and tuning into this webinar. I hope I've shone a small amount of light on what you might want to do to solve your scaling issues and to allow you to design to avoid scaling issues using scaling with replicas and scaling with indices inside there. So thanks very much for that one, and look forward to seeing any of you at any of our events, whether those be whether it's the Elastic on Tour or any of our training events. Enjoy your Elastic journey and look forward to seeing you all again soon. Okay, bye now.